All right, Miss Smith here and
Miss Fowler.
8th grade science teachers here at Wesleyan. We are going to quickly give you a little tutorial on the density problems we have been working on in science. So, what method are we using, Miss Fowler?
So the first method that we're going to use is we're going to find density using the displacement method, okay? Displacement is a method that we use to find the volume of an object that does not have a regular shape. So we know that the formula for volume is length times width times height. But what about when we're taking the volume of something that we can't just measure the length times width times height, say a nail? During those moments, beautiful. During those moments, we have to use a different method, the displacement method, and it works the same way as this. Say that you want to go take a bath, and you put water in the tub, and you put it to a certain amount, a certain height in the tub, and then you get into the bath. What does the water do? It rises. You've displaced the water, and actually, your volume is how much the water has raised by. So we're going to use this displacement method, but we're going to first prove to you that it works.
Okay, so like Ms. Fowler said, you can use the displacement method and you should use the displacement method whenever you can't find exact length and width and height measurements of an irregular object, like a nail. So we're going to use, however, a regular shaped object, this aluminum rectangular 3D shape that we could find the length and width and height of in centimeters. So I found that my length was 4 centimeters, my width was 2 centimeters, and my height was 1 centimeter. I used the standard volume equation, length by width by height, to get a volume of 8 centimeters cubed. So I have a known volume of this aluminum rectangle. I'm going to prove the displacement method works by placing that rectangular prism into this graduated cylinder. We started at a level of 60 milliliters. This one is not working. That's okay. We will use a different one. A known volume of 60 milliliters. And when I place this rectangle into the graduated cylinder, this is a better replica of what I did earlier, I went from 60 milliliters and it jumped up to 68 milliliters. That was my new volume for how many milliliters was in this graduated cylinder. How many milliliters did it change by? 8 milliliters. We know that 1 milliliter is equivalent to 1 cubic centimeter, proving that the displacement method works perfectly. 8 centimeters cubed with our known length and width by height, and 8 milliliters worth of volume in this graduated cylinder. So we are able to get a known volume by using the displacement method. To further move on to finding the density, Ms. Fowler, what is the equation for density?
All right, the equation for density is mass divided by volume. Now, if you can't remember that, that's okay, because as our wonderful student Jules represented earlier in another video, which you can reference on Blackboard on the bulletin page, okay, we love density. But also, the heart serves a double purpose. Okay? The M on the top comes from the top of the heart, and then the V, the bottom of the heart, looks like a V. So this is a great way to remember that density equals mass divided by volume. So we have found the density of our aluminum block using the displacement method, and then we can find easily the mass of the aluminum block using a scale. So all we have to do is turn the scale on, put the aluminum block on the scale, and we have already done this in a predetermined time, and our mass is 21.3 grams. So, remembering that density equals mass divided by volume, we're going to take our mass, which is 21.3 grams, and we're going to divide it by our volume, which is 8 milliliters, okay? And we're going to do 21.3 divided by 8, which gives us 2.66 grams per milliliter. Notice that my units for density are the exact same thing that I put when I divide, okay? Maybe I'll get that M in there. There we go. So, 2.66 grams per milliliter. This is how we find the density of an irregularly shaped object when we don't necessarily know the volume. Thank you for watching!